So good morning to everyone. Good morning. Okay. So what I will do is, before starting with the class, that is today's session, as usual, we will have a discussion on whatever has been taught in the last class. Fine. Now, when it comes to last class, what and all we have discussed, you can put a word, not exactly concept, you can put a word. I want to see how many of you remember what and all we have discussed in the last class. Okay, so still you should put a word. Okay, I will tell. So we have discussed about brown ring test, right? So that was the one main concept which we have discussed. So what is brown ring test? Which is meant for the determination of, yes, black phosphorus, yes, Ravikant. So before that we have discussed about brown ring test, which is meant for the determination of nitrate ion in a given solution, right? So where what they will be using? They will be using ferrous salt, which will get converted into ferric form. Now whatever leftover ferrous is there, it will react with, naturally ferrous will be in the form of hexa aqua complex, which will get converted into penta aqua and nitro complex, right? So that's where we have the brown ring test, which will give brown color. So which is that final product? Yes, we have discussed about phosphorus allotropic forms. Many students they are writing, very good. So that's where we have Fe, NO, then H2O, 5, right? So that's where this is the one which will give brown color. This is the one which will give the brown color, right? So that's what we have discussed. Yes, Bharat, brown ring test. So next, already people have mentioned, very good. So then we have discussed about allotropes of phosphorus, right? So allotropes of phosphorus, where we have discussed about white phosphorus, which can be, molecular formula can be P4, then red phosphorus, which is a polymeric form of P4, that means polymeric P4 molecules will be attached to each other. Then we have discussed about black phosphorus, right? And in black phosphorus we have alpha and beta type. Now when it comes to white phosphorus, all of us we know it is poisonous. It is poisonous, highly reactive, right? Whenever this one will be exposed to the atmosphere, what will happen? There will be formation of phosphorus pentoxide. So what is the formula? P4O10. This one empirical formula, since that one will be O5, therefore it will be called as phosphorus pentoxide, right? So that is one thing. When it comes to red phosphorus, it is polymeric in structure. Red phosphorus will be polymeric in structure, and which will be derived from white phosphorus only. When white phosphorus is heated, then only there will be formation of red phosphorus. Then comes this black phosphorus, where we have alpha and beta. So it can be rhombic or monoclinic crystal structure. That means unit cell will be rhombic or monoclinic type in a crystal structure. This will form flaky layered structure. This will form flaky layered structure. So that's where we have alpha black phosphorus and beta black phosphorus. Fine. So that's what we have discussed. And alpha black phosphorus will be derived from red phosphorus. How to remember this one is, which is first, here it comes red, which is second, here it comes white. Fine. So that's how you can remember. If by chance, if they ask in the exam, until now they have not asked, but they have asked poisonous allotrope of phosphorus. Name the poisonous allotrope of phosphorus, then molecular formula for white phosphorus. That and all you can expect, and that means they have asked. That is related to allotropes of phosphorus. Then we had discussed about phosphorus and its compound, especially with respect to phosphorus halides. Right? So that's where we had discussed about PCl3 and PCl5. First thing, with respect to preparation, limited amount of chlorine, it will give rise to PCl3. So limited amount of chlorine with white phosphorus, it will give rise to PCl3. Right? So white phosphorus with low concentration of chlorine, it will give rise to PCl3. So P4 with high concentration of chlorine, then it will give rise to PCl5. Right? Same way, another method for preparation is white phosphorus when treated with anyone. I am talking about preparation of PCl3. Anyone? Thionyl chloride, that is SOCl2. But here it will be P4 plus SO2Cl2, that is sulfuryl chloride. So thionyl chloride, sulfuryl chloride. So that's where we have the different reactor. So until this we had discussed in the last class, that is with respect to preparation. Right? Now we will move to the chemical property. What is that difference between PCl3 and PCl5? Okay? So as I have told, you can expect this one, or I can write it as important. Okay? Now we are going to discuss about chemical properties of PCl3 and PCl5. So here I am using short form. Don't use that one in exams and all. Fine? So now, when it comes to hydrolysis, PCl3 in the presence of water, PCl3 in the presence of water, it will give rise to formation of H3PO3. H3PO3. Anyway, structure we have to discuss. It is there in your syllabus. Now this molecule will be called as orthophosphorus. Orthophosphorus acid. Orthophosphorus acid plus any product. It has to be there because chlorine, it has not come. It will be HCl. It will be HCl. Okay? So that's where we have the reaction. Whether we have to balance it? Yes, we have to balance. So here it is 3 oxygen, here it is 1 oxygen. So we will, for time being, we will make it as 3. Okay? Now 3, 1, 4, here it is 6. So now, anyway, here it is 3 chlorine is there, we will make it as 3 HCl. Right? I think it is balanced. Yeah, it is balanced. Okay? So that's where we have the hydrolysis of PCl. Okay? Now, when it comes to hydrolysis of PCl5, now observe it carefully. Now, when it comes to hydrolysis of PCl5, there will be formation of intermediate product which will further it will go for hydrolysis. So, I will not mention that intermediate product. but that intermediate product is phosphoryl chloride, POCl3. Anyway, we'll write it straight equation only. So where the product will be H3PO4 and HCl. H3PO4 and HCl. Now we have to balance it, right? 5 chlorine. So for time being, I will write it as 5HCl. Now 2 hydrogen. Here it is 8. So I should make it as 4. Yes, done. I think it is balanced. Right? So phosphorus, oxygen. Okay, done. It is balanced. So that's where we have the product orthophosphoric acid. Orthophosphoric acid. Now what is the oxidation state of phosphorus in PCl3? Any one of you? What is the oxidation state of phosphorus in PCl3? Fast. Can any one of you tell me? What is the oxidation state of phosphorus in PCl3? Okay, very good. So that is plus 3. Yes, done. So naturally in this case it will be plus 5. Now if you observe, what is the oxidation state of phosphorus in the product? In orthophosphorus acid, what is the oxidation state of phosphorus? Yes, very good. It is plus 3. Right? So if you observe here, it will be plus 5. So that's where we have the different product due to the different oxidation state of phosphorus. Fine? So that's where we have one of the important reaction, and that's where we have the difference. All of you have understood? Fine? Any doubt? Only thing here is, here there will be formation of intermediate product. If you use low amount of water, that will be intermediate product will be the product now. That is phosphoryl chloride, POCl3. But anyway, since final product will be orthophosphoric acid, since we will be using enough amount of water, I have written last product, final product. Fine? So that's where we have the, with respect to hydrolysis of PCl3 and PCl5. All of you have understood? So we will move to the next one. If I take C2H5OH, so what is this C2H5OH? Anyone? C2H5OH. That is alcohol, right? Ethanol. This is ethanol. When it is treated with PCl3, when it is treated with PCl3, so I am writing equation down because I have written PCl5 nearby only. So in your notebook, if you are writing, write it like this one. Okay? So that's where I have the reaction of ethanol. Yes. Rajashekar. Yes. That's where we have the ethanol. When it is treated with PCl3, one of the product will be C2H5Cl. Ethyl chloride. One of the product will be ethyl chloride. Okay. Now, can anyone tell me what will be the another product? Because still we have to get phosphorus, still we have to get oxygen in the product side. Oxygen and phosphorus. So therefore, it will be H3PO3. That is orthophosphorus acid. H3PO3. That is orthophosphorus acid. Okay. Now, if I take ethanol and if I treat with PCl5, now the product will be slight variation. In case of the PCl5, there will be slight variation. Okay? So there is no question of orthophosphoric acid. Some people they may think orthophosphoric acid will be another product. So it will be C2H5Cl, ethyl chloride, common product. Here also, there also. But another product will be, because I will give a hint. This OH, since highest oxidation of phosphorus is there, even this OH will be split. So here what is happening? Since phosphorus is intermediate oxidation state, it was not getting split. Right? What I mean to tell is OH is as a product in H3PO3 it is there. But when it comes to here, we are not going to get that one as OH. To make you understand, I am telling, we have mechanism of it. Now, what can be the product in that case? I can give a hint. In this reaction, there will be formation of fumes. Okay? So now I can ask that when PCl3 or PCl5 are exposed to moisture or water, what is moisture? Nothing but water containing atmosphere. So when it is exposed to moisture, then there will, okay, Rajesh, okay, Amit, okay, fine. So HCl, very good. Nishchita, yes, another product should be HCl. What I was telling here was, why there will be formation of fumes when PCl3 and PCl5 are exposed to moisture or water? The answer should be HCl. Answer is not orthophosphorus or orthophosphoric. No, it is because of the HCl. So here also same thing. There will be fumes. So that's where we have the, but not as like this, hence fumes will not be there. So that's where we have the HCl. But still, we have not got the phosphorus in the product. Right? So that's where we have the POCl3, phosphoryl chloride. POCl3 is nothing but phosphoryl chloride. Okay, so that's where I have the product. Yes, it is there. So that's where we have the phosphoryl chloride. So find the difference. One product is constant, but another product is different, right? So that's where we have the reaction. We will see whether it is balanced. Oxygen is 3, oxygen is 1. Okay, then we have to balance it. So here, okay, fine, 3 and 3. I think it is balanced, right? So it is balanced. That's where we have the balanced equation. This side we will see. So chlorine, phosphorus. Oh, okay, students friendly. With PCl5 it is student friendly. Why? Already it is balanced. Why to give trouble to students? That's why it is balanced. Fine? So that's where we have the difference. All of you have understood? Now same way, now this one you have understood, right? The question can be, why there will be formation of fumes when PCl3 or PCl5 will be exposed to water or moisture? The answer should be due to the formation of HCl. Or they can ask, write the reaction involved when PCl3 will get hydrolyzed. So which is that reaction? Whatever we had written here. PCl3 with water will give rise to H3PO3, that is orthophosphorus acid and HCl, right? But when it comes to PCl5, it will be orthophosphoric acid. Fine? Anyway, we are going to discuss about that chemical. Now another important reaction here is acetic acid. What is this? Acetic acid or ethanoic acid. Acetic acid or ethanoic acid. So when it is treated with PCl5, now it will form similar product as that of the ethane. It will form similar product as that of the, PCl5 had written, it should be PCl3. Fine. So in that case, product will be same, where OH minus will be taken care by Cl minus. CH3COCl. What is this molecule? Name of the molecule? Anyone? We have discussed this one, where Friedel-Crafts reaction. No. We have discussed this one in Friedel-Crafts reaction. That is acetic acid, fine. But I am talking about CH3COCl. This one we have to use. We used to use that one in acylation reaction with respect to Friedel-Crafts reaction. Right? So this is nothing but acetyl chloride. Right? So that's where we have the acetyl chloride. And another product will be acetyl chloride, and another product will be same as that of the earlier reaction with ethanol. Same type of reaction. Another product will be H3PO3. H3PO3. Whether we have to balance the equation, we will see. So now if I take phosphorus, okay. So chlorine, here it is 3, here it is 1. So I will make it as 3. If I am making this one 3, this should become 3. Now we will see. Oxygen 314. Okay, 6. It is becoming 6. Oh, here also it is 6 only. So carbon, okay, 3. Okay, done. It is balanced. Right? So we can check it out. So 3, 6. It's correct only now? Or hydrogen, I don't think. It's balanced. It's balanced equation now. Okay? Now next one. Same way with respect to PCl5. With respect to PCl5, acetic acid will form the similar type of reaction. So that means we should get acetyl chloride, then HCl, and then POCl3, phosphoryl chloride. Phosphoryl chloride. Fine? So that's where we have the reaction. So phosphoryl chloride. So if you practice this one, any one, you can write reaction for both. Right? So that's where we have the reaction with PCl5. All of you have understood? Fine? I think it should be balanced, because since here it is balanced, we will see. Okay, it is balanced only. Fine. Student friendly. PCl5 is student friendly. Okay? So that's where we have the difference between PCl3 and PCl5. Any doubt in this? Okay, that's where we have the difference in the PCl3 and PCl5. Now I will be writing reaction which is specific for PCl5. I am not talking about the difference between PCl3 and PCl5. I am talking about reaction meant for PCl5. Okay? Say for example, if I take PCl5, it can undergo for thermal decomposition. It can undergo for thermal decomposition. What can be the product? So it will be PCl3 and Cl2. Yes, it should be PCl3 and Cl2. Yes. So that's where thermal decomposition for PCl5. So that's where we have the thermal decomposition for PCl5. Okay. So now same way, since phosphorus is at highest oxidation state, therefore when it is treated with metals, it will oxidize the metals, because central metal atom is in its highest oxidation state. So therefore it's going to oxidize the metal. So this is another reaction. First one is thermal decomposition. First one was thermal decomposition. Now I am talking about oxidizing character of phosphorus. That is PCl5. That means when silver is treated with PCl5, you are going to get silver chloride and silver chloride and PCl3. Silver chloride and PCl3. Fine. So from zero oxidation state, silver is becoming +1. It is attaining +1. Phosphorus from +5, it is becoming +3. So that's where we have the redox reaction. That means PCl5 is acting as a oxidizing agent, right? So it is taking how many electron? 2 electron. So it is donating how many electron? 1 electron. So therefore we have to multiply. We have to multiply the equation. So since here it is 2, since here it is 1, 1 should be multiplied to here and 2 should be multiplied here. That means 2Ag plus PCl5, then 2AgCl plus PCl3. Done. Equation is balanced. Right? So that's where we have the oxidizing character of PCl5. So why PCl5 is acting as oxidizing agent in this regard? It's not a strong oxidizing agent, but still. Why it is acting as oxidizing agent? Because central atom is in its highest oxidation state. Fine. So these are some of the additional reaction which is applicable for PCl5. Quite important because hydrolysis they had means decomposition they had asked. Now next important point here is which people might have discussed. When it comes to PCl5, it can be in gaseous state also, it can be in solid state also. Fine. Now if you see the structure, we have the phosphorus, then chlorine, and these 3 chlorine will be in one plane. They will be in one plane. 3 chlorine and phosphorus, they will be in one plane. Now another 2 chlorine, one will be here and another one will be here. So this is related to covalent bond. So don't get confused. So this is covalent bond. Fine. So rest of them is, I wanted to show it as a plane. That's what it has become. Okay. So like this it will be present. And these 3, they will be in one plane. These 3 chlorine with phosphorus will be in one plane and these 2 chlorine will be in one plane. Means 2 different planes. Now you should tell me. See for example, okay fine, this is one plane, my hand, and one chlorine is above and another one chlorine is below. That's what. Okay. Now since you people have studied this one in your first PU, Whisper theory, VSEPR theory, that's where you people have discussed. Now you should tell me whether all the bonds present in PCl5 are equal. No, they are not equal. Why? They are not equal. Yes, they are not equal. That is because if I consider this one as axial bond and this one as equatorial bond, axial bond will be always greater than that of the equatorial. Yes, Ravikant, they will not be equal. So that's where we have the axial bond. One is below, one is above. That one will be considered as axial covalent bond. And whatever in the same plane, it will be considered as equatorial. So whatever is there in the same plane, they will be of smaller length compared to these 2. That's because, as you people know, that is due to repulsion. That is due to the repulsion of electrons here and these electrons. They will be repelled. So therefore, these 2 chlorine will be a bit far from the phosphorus compared to these 3. That is one thing. naturally they will show trigonal bipyramidal structure. They should show trigonal because one pyramid is above and another one pyramid is below. So it looks like this. So two pyramids, one is here, one is here, two pyramid. So trigonal. So base is trigonal. So trigonal bipyramid, right? So that's where PCl5 will have the structure. Trigonal bipyramidal structure. Fine? Any doubt? Now another very important point here is, in one of the exam, I have forgotten whether it is a board exam or competitive exam. When it comes to PCl5, in solid state, very important point here is, in solid state, it will be like a ionic compound or ionic crystal. It will be like a ionic crystal where it will be having PCl4 plus and PCl6 minus. So that form it will be there. It will be a complex of these two forms. Ionic compound. It will be like a ionic crystal. In solid state, please remember, only in solid state, not in any other form. Only in solid state it will be ionic form. Now naturally, since it is PCl4, what is the hybridization? sp3 hybridization, right? It is sp3 in this case. So it will be forming tetrahedral structure, right? It will be forming tetrahedral structure. If you come here, so total how many bonds are there? PCl6. So that means plus 2, that means D2, right? So sp3 D2 hybridization is there. Now it will form octahedral. Naturally, since 6 bonds, covalent bonds are there, it will form octahedral. So that's where we have the component of cationic form, anionic form. Cationic form will tetrahedral form, anionic form will be octahedral form. So that's where PCl5 in solid state, it will be like an ionic crystal. This one they had asked. Fine. So therefore, any doubts with regard to PCl5 structures? Fine.
So PCl6 is it not square like
Octahedral because 6 is there, na? Why bipyramid? Bipyramid will not come. Bipyramid will not come because even number it is 6. Okay, therefore it can be octahedral. Any doubts? So shall I move to the next one then? That is oxo acids of phosphorus. Next one will be oxo acids of phosphorus. I will tell very, very, very important. Same as that of the Haber's process or Ostwald's process. Here it is also very, very, very important because for 1 mark they will ask to write the structure. That is orthophosphorus. That means oxo acids of phosphorus. Now, first thing we should know what do you mean by oxo acids. Oxo acids are those compounds which are having OH linkage. That means which is going to donate the H plus by dissociation of OH bond. Those type of acids are called as oxo acids. So what do you mean by oxo acids? Oxo acids are those acids where H plus will be released due to the breaking of the bond present between oxygen and hydrogen. So due to that, there will be liberation of H plus. So these type of acids can be called as oxo acids. For example, sulfuric acid is an oxo acid of sulfur. but HCl is not an oxo acid. Fine. So whether I am clear, that's where we have the oxo acids. Now one of the important oxo acid is H3PO4. H3PO4. Right? So now the name of the molecule here is orthophosphoric acid. That's what we have discussed in the just 10 minutes before. That's where we have the orthophosphoric acid, H3PO4. Fine. Now we have the phosphorus. 4 oxygens are there. So 1, 2, 3, 4. 4 oxygens are there. Right? Now phosphorus will be left over with 1 electron. Because what is the total valence electron in phosphorus? 5. 1, 2, 3, 4, 5. So 1 electron is left over. Unhappy. Phosphorus will be very, very unhappy. It's left over with lone electron. So therefore, it will request any one of these oxygen. See, I am left over with 1 electron. Can you do something? Because even these oxygens are left over with 1 electron. If you observe, oxygen valence electron is 6. In that 1 is involved in the bond formation, and there will be left over 5 electrons. So that means even oxygens are left over with lone electron. So therefore, phosphorus, any one oxygen, it can make double bond. Now oxygen, one oxygen and phosphorus, they are happy because no lone electron on one of the oxygen, which will make the double bond with the phosphorus. Right? Now but these 3 oxygen, they are very unhappy. So to make them happy, there will be formation of bond with the hydrogen. There will be formation of bond with the hydrogen. Right? So therefore H3PO4. So I can write it as OH, OH and OH. Fine. So lone pair of electron, no need to show. To make you understand, I have shown in the structure. If you remember, if you show the lone pair of electron, don't worry, it's not wrong. But it's not compulsory. But structure will be like this. Don't by heart. That's how you should write the structure. Fine. So that's where we have the orthophosphoric acid. Now can you try it out? Orthophosphorus acid, H3PO4. Sorry.
So why is it called ortho?
Ortho because it will be having lots and lots of water. It can hold the water. So one is, that is the reason. Another one is based on the structure. It looks like a linear type of structure. Therefore ortho. Okay, fine. The question was with respect to ortho. Why it is called as ortho? Normally ortho stands for linear structure. Fine. So that might be the reason why they have given it as orthophosphoric acid. But along with that, it can hold some amount of water, orthophosphoric acid. If you take crystal of orthophosphoric acid, after few days, it will not be like pure crystal. It will be holding the water molecules. So that might be the reason. Okay? So that's why we have the orthophosphoric acid. Next one is orthophosphorus acid. Orthophosphorus acid. Write the structure. Still we have. First, all of you have written? Okay, I will write reverse. Okay, so this is ortho phosphorus acid. Naturally, we have the phosphorus and 3 oxygen. Right? I have the phosphorus and 3 oxygen. Now, phosphorus is left over with one lone pair of electron, and each oxygen with one lone electron and 2 lone pair of electron. Oxygen, they are unhappy now. Right? So what they will do? Any of these 2 oxygen, they can make the double bond. They will ask phosphorus, will make double bond. You have left over with 2 electron. So oxygen, phosphorus will agree. So it will make double bond and it will make double bond. Any of these 3 oxygen. It's not compulsory that only these 2 oxygen. Even this oxygen can make, but any one of these 2 can make the double bond. 1 minute. H3PO3. H3 is there now. Fine. Okay. So it will make the double bond. Next. Only one, not 2, only one, because 3 hydrogen is there. Only one will make the double bond. Okay. Now, this oxygen will take the hydrogen, or this oxygen will also hold the hydrogen. Still we have one hydrogen left over, and still we have one electron left over on the phosphorus. So what it means? That means one hydrogen will be directly bound to phosphorus. One hydrogen will be directly bound to phosphorus. So here it is H3. So 2 oxygen cannot make the double bond. Fine. So since H3 is there, so one hydrogen will make direct bond with the phosphorus, and there will be one double bond between any of these 3 oxygen, and whichever 2 oxygen will not have the double bond, they will hold the hydrogen. Fine. So that's where we have the orthophosphorus acid. Now we have hypophosphorus acid. Now, normally hypo stands for holding less water molecules. Hypo. Fine. Hypophosphorus acid. What can be the structure? H3PO2. Fine. So we have phosphorus and 2 oxygen. We will write down 2 oxygen. Fine. Now, any one of these oxygen can make the double bond, because to satisfy, to avoid the lone electron. Now if you observe 1, 2, 3, 4, 5, oxygen is having one lone pair of electron. So what it will do is, instead of making double bond with the oxygen, this will make bond with one hydrogen and another hydrogen, and this oxygen will hold the water. So that's where we have the hypophosphorus acid. That's where we have the hypophosphorus acid. Fine? All of you have understood? So this is hypophosphorus acid. Now this one is pyro compound. That one is pyro compound. Pyro stands for where 2 phosphorus or 2 element link through oxygen. Pyro. So that is pyrophosphoric acid. Fine. H4P2O7. So that means among 7, 1 is utilized. So still 6 are there. So we can make it as 1, 2, 3. So 1, 2, 3. Oh, sorry. So that's where we have the oxygen. Now, phosphorus lone electron is left over, right? So it has to make double bond with any of these three oxygen. It will make double bond with any of these three, not with this oxygen. Fine. Now 4 hydrogen, 1 and 2 here and 2 here. So that's where we have the pyrophosphoric acid. This is nothing but pyrophosphoric acid. Fine. All of you have understood? So that's where we have the oxo acids. Newly important one I have written. So that's where we have the pyrophosphoric acid. H4P2O7. You should know the molecular formula. If you know the molecular formula, you can write it down the structure without by hearting. But you should know the molecular formula. All of you have understood? Fine. Now I will remove this pyrophosphoric acid. I will remove this pyrophosphoric acid. Now, if you observe these three, I can see orthophosphoric acid is the one which can donate 3H plus. It can donate 3H plus, right? So now, when it comes to orthophosphorus acid, it can donate 2H plus. Fine. And now, when it comes to hypophosphorus acid, it can donate only 1H plus. Right? So, whichever hydrogen is directly attached to phosphorus, they will not be released as H plus so easily. But whichever hydrogen is attached to oxygen, because since oxygen is highly electronegative, so that's where it will be released as H plus. So, what I mean to tell here is, you can remember based on the amount of OH linkage, basicity. So based on that orthophosphoric acid, if I want to talk about basicity, then I can tell that orthophosphoric acid is having 3, which is greater than that of the orthophosphorus acid, which is having 2, which is greater than hypophosphorus acid, which is 1. So based on the number of OH bond. Fine. So based on basicity I can tell, like ammonia, nitrogen, NH. Nitrogen is electronegative, right? Same way. So therefore, basicity, orthophosphoric acid is having higher basicity compared to orthophosphorus, which is having higher basicity compared to hypophosphorus. So what I mean to tell you is, it is decreasing order of arrangement. Even this one they have asked. Same way, if I take reducing character, if I take reducing property, now reducing property will be based on how much hydrogen they can liberate, or in this case you can go with the hydrogen attached directly to the phosphorus. As the hydrogen attached to directly phosphorus will increase, reducing character will also increase. So that means it is in the reverse order. It is in the reverse order. Once again I will repeat. So when it comes to reducing property, hypophosphorus acid is having highest reducing property compared to orthophosphorus acid, which is having higher reducing property compared to orthophosphoric acid. Therefore, when it comes to reducing property, it is increasing in order. And when it comes to basicity, it is in decreasing order. Remember this. Same as that of ammonia, phosphine, bismuthine and all we have discussed, right? Same way here also. There it was nitrogen, electronegative element attached to hydrogen. Here it is oxygen attached to hydrogen. So therefore, basicity is more with respect to orthophosphoric acid, and reducing property is more with respect to hypophosphorus acid. All of you have understood? Any doubt? Anything I have left over? Okay, still I have one reaction. But fine. So that's where we have the basicity and reducing property. Is it short? Is the structure they can ask? or in order, or increasing order, decreasing order for 1 mark, even for reducing property, they can ask. Structure they have asked many times. Fine, for 1 mark. So that's where we have the orthophosphoric acid, orthophosphorus acid, and hypophosphorus acid. Fine. Now one of the speciality of orthophosphorus acid is that is H3PO3. Speciality here is it can undergo disproportionate reaction. It can undergo disproportionate reaction. Okay na? So when you heat it, it can undergo disproportionate reaction. Yaake andre oxidation state of phosphorus is +3. It's not high also, it's not low also. It is intermediate. So intermediate oxidation state is that. Therefore, it can undergo for disproportionate reaction. So that's where we have H3PO4 as one of the product, and another product will be phosphine. Another product will be phosphine. That's where disproportionate, where one will be with highest oxidation state, another one will be with lowest oxidation state. That's why it is called as disproportionate reaction, right? So that's what it will happen. +3. Now here we have +5 and here we have -3. So that's where I am talking about phosphorus. So that's where we have the disproportionate reaction. I think we have to balance. Okay, we'll do one thing. We'll pick the oxygen. Rarely occurring. Oh, it's very easy. So multiplied by 4, multiplied by 3. Because here it is 4 is there, I have utilized the 4. Here 3 is there, I have added 3. Equation should be balanced. Done. It's balanced. So that's where we have the disproportionate reaction. Why orthophosphorus acid will go for disproportionate reaction, not orthophosphoric? Orthophosphoric cannot show the disproportionate reaction. Orthophosphorus acid can show the disproportionate reaction. What is the reason? The reason here is, in case of orthophosphorus acid, central atom, not metal, central atom is in intermediate oxidation state. It's not too high, it's not too low. So therefore it will go for disproportionate reaction. Fine? All of you have understood? Any doubts? Okay. So by this group 15 elements we have finished. By this group 15 elements we have finished. Fine? So we will go with the group 16. So give me another 2-3 minutes. Briefly I will tell. I will give introduction to group 16 elements. I will not take much time. Don't worry. So when it comes to group 16, right? So which is also called as oxygen family. They are oxygen family. After nitrogen family it is oxygen family. That is because oxygen is the first element in this group. Even they will call it as chalcogens. They will call it as chalcogens. Fine? So that is because some of its ores or minerals are with copper. So that's where it is chalcogens. It can also be called as chalcogens. Fine? So group 16 elements. Now, as I have told, since it is group 16, they should have the 6th valence electron, or outermost electronic configuration should be Ns2 Np4. So total 6 valence electron, Ns2 Np4, outer electronic configuration for group 16. Now, if you want to go with group 16 element, first one will be oxygen, then sulfur, then selenium, then tellurium, then polonium. Right? So oxygen, sulfur, selenium, tellurium, polonium. So these are the group 16 elements. What is the another name for group 16 element? Chalcogens. Why they are called as chalcogens? Because some of their ores are in combination with the copper. So that's why they are called as chalcogens. Now oxygen, sulfur, selenium, tellurium, polonium. These are group 16 elements. So among these, oxygen and sulfur, they are non-metals. Selenium and tellurium, they are metalloids. And polonium is a metal, but along with that, it is a radioactive element. Polonium is a metal, and along with that, it is a radioactive element. One more question can be asked. Name the radioactive element in group 16. So which is that one? Polonium is the radioactive element in group 16. And with the half-life, approximately 13.8 days. So approximately half-life will be approximately 13.8 days. Since we are talking about radioactive element, I am mentioning half-life 13.8 days. Fine. So this is with respect to group 16. So what I will do is in next class, that means Monday's class, we will go with electronic configuration. Then we will start with the properties. Okay. Properties of group 16 elements. Any doubt? So what you can do is by Monday you can be ready with Haber's process, Oswald's process, then PCl3, PCl5, then allotropes of phosphorus, and even structure of oxo acids of phosphorus. Okay, so there are many concepts. That's what I told. Group 15 is like it's a very large chapter. So don't keep anything pending. It will be a burden for you. Fine. So try to practice whatever concept I have told. So we have done with the group 15 element, and among the P block, group 15 is bit more larger in the P block. Then comes 16, 17, 18. But among this 15, we have huge, or it's bit more compared to other group elements. Fine? Okay then. Take care. Take care. Bye. Thank you. Thank you everyone.